So for today, I'm going to discuss Math 9 Module Quarter 1, Week 5. Solving problems involving quadratic equations and rational algebraic equations. Let's have first what's new, Activity 1. Let's review. So this is just a review on the last topic about solving quadratic equations. So directions: solve the following quadratic equations by A. Extracting the square roots, B. Factoring, C. Completing the squares, and D. Using quadratic formula. So you're going to solve these two numbers here using the four methods. Then activity 2, solve me, directions. Use the situation below to answer the question that follow. So in the problem here, the length of the rectangular malong is 5 meters longer than its width. The area of the malong is 84 meters squared. So you have their process questions. So this will be your guide in answering the problem. So the length of the malong here is 5 meters longer than its width. So we can have the length, or represent the length as L equals W plus 5. And we're going to use here the formula area equals length times width. So this will be your guide in answering the activity. Next is what is it? So the concept of quadratic equations is illustrated in many real-life situations. Problems that arise from these situations, such as those involving area, work, profits, and many others, can be solved by applying the different mathematical concepts and principles previously studied, including quadratic equations and the different ways in solving them. Let us study and understand these examples. So example number 1, the top of a rectangular table has an area of 27 feet squared and a perimeter of 24 feet. What is the length of the top of the table? What is its width? So for the solution here, the sum of twice the length and twice the width of the rectangular table gives the perimeter. Hence, 2L plus 2W equals 24. Okay, so this is from the formula perimeter equals twice the length plus twice the width. Now if we divide both sides of the equation by 2, then we can have L plus W equals 12. Then the product of the length and the width of the rectangular table gives the area. Hence, length times width is equal to 27. So 27 here is the area of the rectangular table. Then in here we can think of length times width equals 27 and length plus width, or L plus W equals 12, as the equations representing the product and sum of roots respectively of a quadratic equation. So remember that if the sum and the product of the roots of a quadratic equation are given, the roots can be determined. So this can be done by inspection or by using the equation x squared plus b over ax plus c over a equals 0, where c over a is the sum of the roots and b over a is the product. So by inspection, the numbers whose product is 27 and whose sum is 12 are 3 and 9. So 3 times 9 is 27 and 3 plus 9 is 12. So the roots of the quadratic equation then are 3 and 9. So this implies that the width of the table is 3 feet, the shorter one, and the length is 9 feet, the longer one. So if we're going to check this one, area is equal to length times width. So 3 times 9 is 27, so 27 feet squared. And the perimeter is 24, so 3 times 2 is 6, 9 times 2 is 18, so 6 plus 18 is 24. Then another method of finding the roots is to use equation x squared plus b over ax plus c over a equals 0. So we can let here negative b over a equals 12 and c over a equals 27. Then substitute these values in the equation. We can have x squared plus b over ax plus c over a equals 0. We can have that one as x squared plus negative 12x plus 27 equals 0. Then we can have that one as x squared minus 12x plus 27 equals 0. Then solving this one by factoring. So we can have the factor as quantity of x minus 3 times quantity of x minus 9 equals 0. Then using zero product property, x equals 3 and x equals 9. So the same answer with the first solution. Then example 2, the local government of Iligan City wants to place a new rectangular billboard to inform and give awareness to the Iliganons on how to protect themselves from the spread of COVID-19. Suppose the length of the billboard to be placed is 4 meters longer than its width and the area is 96 meters squared. What will be the length and the width of the billboard? So for the solution, if we represent the width in meters of the billboard by x, then its length is x plus 4 from the given length is 4 meters longer than its width. So we can have length as x plus 4. Then since the area of the billboard is 96 meters squared, we can have x times the quantity of x plus 4 equals 96. That is width times length equals 96. Then solve for this one. X times quantity of x plus 4. We can have that one as x squared. Then x times 4 is 4x. Then equals 96. Then writing this one to standard form, x squared plus 4x minus 96 equals 0. Then solve the resulting equation by factoring. So you have there quantity of x minus 8 times the quantity of x plus 12 equals 0. Then using zero product property, x minus 8 equals 0. So x here is equal to 8. Then x plus 12 equals 0. X is equal to negative 12. So the equation x squared plus 4x minus 96 equals 0 has two solutions, x equals 8 or x equals negative 12. However, we only consider the positive value of x since the situation involves measure of length. Hence, the width of the billboard is 8 meters and its length is 12 meters. So you can check that one using the given area. Then example number 4, the Rural Bus Incorporated travels around the island of Mindanao. Last December, Jose visited Siargao Island. He observes that the speed of the bus decreased by 10 kilometers per hour. It took 2 hours more than what it usually takes to cover a distance of 1,800 kilometers. Find the time it usually takes the bus to travel from Iligan City to Surigao City. So for the solution, the data is tabulated below. So you have there the speed or the rate, then time, then the distance. Now for the speed, u, substitute the speed by u and t for time. So u times t equals 1,800, the total distance. Then if the speed is decreased by 10, so you have there u minus 10. It will take 2 hours more than it usually takes. So we are going to have t plus 2 for time, then the same distance 1,800. Now, since the 2 are equal to the same distance 1,800, so you can say that u times t is equal to the quantity of u minus 10 times the quantity of t plus 2. Then solving that one, we can have u times t is ut, then u times 2 is 2u, then negative 10 times t is negative 10t, then negative 10 times 2 is negative 20. Now, since u times t is equal to 1,800, so we can have this one as 1,800, then plus 2 times u, then minus 10 times t, t is 1,800 over u, so minus 10 times 1,800 over u, then minus 20. This is equal to 1,800. Now, if we're going to transpose 1,800 to the left side, we can cancel this one. 1,800 minus 1,800 is 0. So this will become 0 here. Then we can have 2u Then 10 times 1,800 over u is 18,000. So minus, this is minus 18,000 over u, then minus 20 equals 0. Okay, then eliminating u here, multiply both sides by u, so we can have 2u squared. Then u times negative 18,000 over u is 18,000, so minus 18,000. Then u times negative 20 is negative 20. U equals 0. So we can simplify this one. We can simplify 2u squared minus 18,000 minus 20u equals 0 by dividing by 2. So we can have 2u squared divided by 2 is u squared. Then negative 20u divided by 2 is 10u, so minus 10u. So we are arranging here the terms. Then negative 18,000 divided by 2 is negative 9,000. So negative 9,000 equals 0. Then solving for the value of u here, we're going to have this one here, u minus 100 times quantity of u plus 90 equals 0. That is u equals 100. So we have given t equals 1,800 over u. So 1,800 over 100, that is 18. So the bus here will usually take 18 hours to travel from Iligan City to Surigao City. 18 hours. Then example number 5, Juan has a rectangular garden in their backyard. One day, obeying the stay-at-home policy of the government, he plans to replant the vegetables in his garden since it was not replanted after the fruitful harvest last year because of his new work. The length of the rectangular garden is 6 more than the width. The area is 27 square units. Find the dimensions of the rectangular garden. So for the solution, we can let x as the width. This one here is the width, x. And x plus 6 is the length. So from the given, the length of the rectangular garden is 6 more than the width. So we are going to have x plus 6. Then the area is 27. So we're going to have x times the quantity of x plus 6 equals 27. Then solving for this one, x times x is x squared. Then x times 6 is 6x. Then equals 27. Then you can have x squared plus 6x. Then transposing 27 to the left side. Minus 27 equals 0. Then solve the quadratic equation by factoring. So you have there x minus 3, quantity of x minus 3 times quantity of x plus 9 equals 0. Then solving for x using zero product property, x equals 3 and x equals negative 9. So since we let x as the width, so the width here will be 3 and the length is equal to x plus 6. So substituting x by 3, we are going to have 3 plus 6 and that will be 9. So the dimension of the rectangular garden is 9 by 3. Activity 3. Let's do the solving. So directions, answer each of the following. So you have there 5 questions. So kindly solve the problems using the skill that you have learned a while ago. Next is what I have learned. Activity 4, quadratic problems for more. Directions, solve the following problems. So you have there again another 5 problems. So you're going to solve that one. Next is activity 5, show your design. So direction, complete the following task. The rubric is your guide for this activity. Then lesson 2, solving problems involving rational algebraic equations. So what I need to know. So look at the figures below. how are they the same? How are they different? How did they illustrate rational algebraic expressions? You have this one, a times the quantity of b plus c equals a times b times quantity of a times c. So this is just a review on distributive property of numbers or integers. Then the second one, x plus 13 equals 27. Then subtracting 13 on both sides, so you have there x plus 13 minus 13 equals 27 minus 13. So x is equal to 14. What is it? Activity 1, review me. So the direction is study the example and answer the rational algebraic equation. So example 7 over 3x plus 4 over 6x squared equals 5 over 8x minus 2 over 3x squared. So you have there step 1. So in here, 24x squared is multiplied to the equation. So 24x squared here is the number that can divide the denominators of the equation. 3x, 6x squared, 8x, and 3x squared. Okay? Then multiplying the equation, we can have 24x squared times 7 over 3x. So 24x squared divided by 3x is 8x, so 7 times 8x. Then 24x squared times 4 over 6x squared. 24x squared divided by 6x squared is 4, so 4 times 4. Then 24x squared times 5 over 8x. 24x squared divided by 8x is 3x, so we have there 5 times 3x. Then 24x squared times negative 2 over 3x squared. So 24x squared divided by 3x squared is 8. So you have there negative 2 times 8. Then 7 times 8x is 56x. 4 times 4, 16. Equals 5 times 3x is 15x. Then negative 2 times 8 is negative 16. Then 56x transpose 15x to the left side, you have there negative 15x or minus 15x. The negative 16, transpose 16 to the right side, minus 16. So you have there 56x minus 15x is 41x. Equals negative 16 minus 16 is negative 32. So x here is equal to negative 32 over 41. So this is the solution. So for number 1 here, x plus 3 over x minus 4 equals x minus 5 over x plus 4. So the number that you are going to multiply here is x minus 4, quantity of x minus 4, times quantity of x plus 4. Okay. Then same with number 2, you'll just use the denominators, quantity of x plus 1 times quantity of x minus 2. Number 3, you can have the denominators 9x plus 1 and 6x minus 5. And for number 4, x squared minus 1 and x minus 1. X squared minus 1 is the number that can, or the expression that can divide the 2. And you have there 2 in the right side. So you can multiply the equation by 2 times x squared minus 1. Then just simplify. Activity 2, equate me. So direction, read the following situations and give the rational algebraic equation of the problems given. Solve what is asked in the problem. So you have there 3 problems. Then you're going to solve that one. Then what is it? A rational equation is an equation containing at least one rational expression. Rational expressions typically contain a variable in the denominator. For this reason, we will take care to ensure that the denominator is not 0 by making note of restrictions and checking our solutions. So we solve rational equations by clearing the fractions by multiplying both sides of the equation by the least common denominator or LCD. So example 1, solve for x. In 5 over x minus 1/3 equals 1 over x. So solution, we first make a note that x is not equal to 0 and then multiply both sides by the LCD. So in here, the LCD, the number that can divide the denominators of the terms, is 3 times x, so or 3x. So multiplying the equation by the LCD, 3x times 5 over x is 3x divided by x is 3, so 3 times 5 is 15. In here, okay, then 3x times negative 1 over 3, this is 3x divided by 3 is x times negative 1, negative x. Then 3x times 1 over x, 3x divided by x is 3 times 1, this is 3. Okay, then negative x equals 3, then transpose 15 to the left side, so 3 minus 15, that is negative 12. Dividing the equation by negative 1, so you're going to have x is equal to 12. Then you can check by substituting x by 12 in the original equation. So 5 over 12 minus 1/3 is equal to 1 over 12. So 5 over 12 minus 1/3, let's see if this is equal to 1 over 12. So divisible by 12, so 12 divided by 12 is 1 times 5 is 5. Then 12 divided by 3 is 4, times 1 is 4, so 5 minus 4 over 12. So 5 minus 4 is 1, so this is equal to 1 over 12. So this is correct. Example number 2, solve for x in 2 minus 1 over x times the quantity of x plus 1 equals 3 over x plus 1. So in this example, there are two restrictions. X should not be equal to 0, and x should not be equal to negative 1, because if these are the values of x, it will make the equation undefined. So begin by multiplying both sides by the LCD. So we can have the LCD x times the quantity of x plus 1. So multiplying the equation, we can have x times the quantity of x plus 1 times 2. So that will be 2 times x, 2x. Then times x plus 1. Then x times the quantity of x plus 1 times 1 is the same, x times quantity of x plus 1 divided by x times the quantity of x plus 1 is equal to negative 1. So this is negative 1 here, equals x times the quantity of x plus 1 times 3 over x plus 1. Cancel x plus 1, so x times 3 is 3x. Then 2x times x plus 1 is 2x squared plus 2x, then minus 1 equals 3x. Then we're going to transpose 3x to the left side. So we're going to have 2x squared plus 2x minus 3x minus 1 equals 0. So negative 3x plus 2x is negative x. So you have there 2x squared minus x minus 1 equals 0. Then by factoring, we can have this one as 2x plus 1 times the quantity of x minus 1. So zero product property, 2x plus 1 equals 0. Then 2x equals negative 1. Transposing 1 to the right side, then x here is equal to negative 1/2. Then x minus 1 equals 0. Then x is equal to 1. So you have there two solutions. So just check if these two are real solutions or one of these is an extraneous root or solution. Then what's more, activity 3, solving situations. Direction, analyze the following situations, then solve what is asked in each of the problem. Follow the steps suggested. Example situation, the area of one side of the rectangular garden is 2x plus 6 meters squared, where x represents the width of the garden. Find the length and the width of the garden. So given here is x, width of the garden, and x plus 3 is the length of the garden. So using length times width equals area. So you can have x times the quantity of x plus 3 equals 2x plus 6. X times x is x squared. X times 3 is 3x, then equals 2x plus 6. combine like terms. So transpose 2x plus 6 to the left side. So we can have x squared plus 3x, then 2x will become negative 2x, 6 will become negative 6. So we're going to have x squared, 3x minus 2x is x, so plus x minus 6 equals 0. Then by factoring, we can have the factors as quantity of x plus 3 times quantity of x minus 2 equals 0. Then using zero product property, x plus 3 equals 0, x here is equal to negative 3, then x minus 2 equals 0, x here is equal to 2. Now in here we're going to use the positive value of the factor since we are talking of measurements. Therefore the length is 5 meters, so length is x plus 3, so width is 2, so 2 plus 3 is 5 meters, and the width is 2 meters. So you have there 3 situations, so you're going to solve that one. Then what I have learned, activity 4, show me what you got. So direction, analyze the following situations. Solve what is asked in each problem. Specify what is given and is required. Define your variables. Then show your solutions clearly. So you have there 4 problems. So just apply what you have learned. Then what I can do, activity 5, multitasking. So task 1, wooden cabinet. So direction, make a design or a sketch plan of a wooden cabinet that can be made out of a 1 inch by 4 feet by 16 feet plywood. Using the design or sketch plan, formulate a problem that involves rational algebraic equations, then solve accurately. The given scale is 1 cm is to 1 meter. Then the next one is the post-test assessment. So you're going to answer 15 questions. And you have their challenge problems 1 to 4. So kindly solve. So that's it for this video. Thank you and goodbye.